Huh? What? Yeah, it's supposed to be in class anyway. How I know? Okay, so anyway, so what we are going to do today is the first part of hypothesis testing. Okay, so let's go through the steps of hypothesis testing. What are all the few steps? 6 steps of hypothesis testing. 5 or 6 steps. Okay, you have it in your lecture notes already. No, you don't have to memorize, but then you follow the 6 steps. So what's the first step? Identify the noun. It doesn't matter. The steps are the same. No, but what is the steps first? Yeah, correct. So what's the first thing? First thing that you have. Okay. So actually, before you even find the null, before you even define the null and alternate hypothesis, the first thing that you do any experiment is you start off with your research question first. Okay. Research question. This is sometimes also known as your research hypothesis. Practical 4. Okay. So your research hypothesis is actually very important in the first place. Okay. And research hypothesis, later we'll come to that. From research hypothesis, SAC is technically step 0. Before you even do hypothesis testing, you need a research hypothesis first. So step 1, you actually need to formulate your statistical hypothesis. Okay, so you formulate your statistical hypothesis. Okay, now every time you have statistical hypothesis, it comes in pairs. Statistical hypotheses are always in pairs. You have a null and alternate hypothesis. Okay, so this is very important. You have your null hypothesis. Sometimes we define it as H0 and your alternate hypothesis. Okay, some books will write it as H1, some books will write it as HA. Both are acceptable. Okay. So usually, in fact, not all the time, null hypothesis is the hypothesis of no difference. Okay, null hypothesis is actually a hypothesis of no difference. So for example, when you want to look at your research question, let's say you are testing medication. For example, the research hypothesis could be whether, let's say, chemical or drug A, what do you call, suppress, let's say, cancer growth. When you ask this type of question, you also automatically, for research question, you need a control, right? So it's chemical A, suppress cancer growth versus your control. So your control could be just plain pure water or just a media. It depends on what control is. So what happens is your null hypothesis is then there's no difference, which means that chemical A does not suppress the cancer growth as compared to control. Okay, so mathematically, you write this as your null hypothesis. The average of growth in chemical A equals to the average of growth in your control. So in most of the time when our research question, when we want to ask research question, it is actually equivalent to our alternate hypothesis. Our alternate hypothesis in this case is that chemical A, if you are talking about two-tailed test, it will be chemical A affects cancer growth. Okay, so in this case, this is a two-tailed hypothesis. Chemical A affects, which means that mathematically you write it as the average of growth in the presence of chemical A is different to the growth in control. Okay. Your one-tailed test will be in the form of chemical A reduces cancer growth. Okay, so in this form, it will be the growth in chemical A is lower than the growth in control. All right, so one-tailed and two-tailed test, you have to define what is it. Then after that, there's actually another few steps to do. In your hypothesis testing, you also need this thing known as the threshold. Okay, so let's say, for example, in a test, let's say you score 70 marks out of 100. Is it good or bad? 70 out of 100, is it considered good or bad? Good. Okay, but what is your threshold in your head? You say that it's good because you assume that the passing mark is 50, right? What happens if the passing mark is 70? Is it good or bad? You still pass. What happens if the passing mark is 80? Then it's bad, right? You fail. Okay. So the threshold is important. In this case, we actually define the threshold in two different ways. Okay. One method is to define the threshold as the alpha value. Okay. Alpha value sometimes is called the significance. Okay. Alpha value also is the p-value, the probability value. Because we have computers, we can calculate every single probability value out. Now, if you use pen and paper, you are going to use the second method, which is the critical value. So what is the difference between these two? If you look at the area under the curve, so let's say that, for example, you have this, okay? The shaded region. The two shaded region each add up, each is 0.025, two-sided test. So both of them add up to alpha equals to 0.5, the 0.05. Okay, the total shaded area. There's a total shaded area. Okay, that is the p-value. The critical value, let's say this is a t-test or z-test. The critical value is the axis, which means that the t-critical or the z-critical value here. What is the number on the axis? The center is, mean is always 0. Okay. So this is almost like the passing mark. Okay. And what is then the next step? The step 2 is you collect your data. Okay, collect your data. All of you know how to do that very well. The third step is then to decide on the statistical test. And from there, you calculate a statistic, calculate a value. So this statistic is actually critical. You need to calculate the statistic. This statistic can be a T statistic, Z score. It can be a F statistic, can be chi-square test, chi-square statistic, anything. Okay. After that, this is step number 3. Step number 4, you do a decision. You decide to accept or reject null hypothesis. Okay. So what happens is this. Okay. When do you accept null hypothesis? When it's not in the shaded region. You accept the null hypothesis when it's not in the shaded region. Okay. So when I say accept, it means you fail to reject null hypothesis. Okay. So you first, possible A is you fail to reject null hypothesis. If you fail to reject null hypothesis, you then accept null hypothesis. Okay. Once you accept null hypothesis, don't say even a single word about alternate hypothesis. Any word that you say after that is going to be wrong. Okay. So how do you accept null hypothesis? Okay. Accept null hypothesis when one of the two conditions happen. Condition 1 is that the statistic that you calculate is more, okay, accept the null hypothesis, now accept, right? Hold on. When the statistic you calculate is less than the critical value. That means okay, less than critical value. The second condition is look at the p-value. The p-value is more than, no. This statistic is, the statistic is less than the p-value, correct? That when the p-value is actually more than the alpha value that is decide. Okay. Later, the probability value, the area under a curve. Okay. So B, in order for you to accept alternate hypothesis, you have to reject the null hypothesis. By rejecting null hypothesis, you automatically accept the alternate hypothesis. Okay. So how do you do that? It's the reverse. When the statistic is more than the critical value, or the p-value is less than the alpha that you give. So in another words, if I will put it on the graph here, it means that if I drag it out, right, anything inside the unshaded region is that you accept the null hypothesis. Anything after that, you reject null hypothesis, you accept alternate hypothesis. So same here, you reject null hypothesis, you accept alternate hypothesis. Okay. Finally, part 5, you do your interpretation. You interpret your result. Basically, you rewrite whether is null hypothesis correct or is null hypothesis wrong, and is it null hypothesis. You kind of reflect that to the statistical question again. So that is the whole thing about hypothesis testing. Okay, seriously, that's the whole thing about hypothesis testing. So it applies for every single statistics that you use. Now in future, what you're going to change is this. What you're going to change is what is the statistical test you use. And the statistical test will determine how you calculate the statistic. That's all. Based on the hypothesis, based on the data, what statistical test you can use. The method is the same. So this is a template. All right. So we'll go through this again on Thursday, these 4 steps. But we need it so that you know what's going to happen. So far, so good. Now, if you look at these two conditions, it becomes quite clear how we reject and accept our hypothesis already. Okay. So how does it look like? Let's say you have a graph. Okay. So it doesn't matter this is a t-axis or z-axis, it doesn't matter. So it goes over, this is 0. And our shaded region is here. Okay. So condition 1. Okay, let me just write. So situation 1. Okay. If the t calculated is more than the t critical. So remember this point here, this is the t critical. If a t is more than t critical, which means that the t may be here, correct? If t is more than t critical, automatically it implies that the p-value, if I were to do this, shaded the p-value, this black shaded region is going to be less than the alpha region, which is the orange region, right? Okay. Therefore, you reject the null hypothesis. Okay. If the opposite is if t is less than the t critical, which means that if t is here, this is a t for part 2. Automatically, it means that the p-value, the blue shaded region, okay, is going to be more than the alpha. The alpha is this. The blue region is going to be more than the orange region. Okay, and then this is where, oops. You accept the final conclusion, accept the null hypothesis. All right, so that is the whole concept of it. When you accept, when you reject, yes, Ken. Fail to reject null hypothesis means that you accept null hypothesis. You cannot reject means that you have to accept. Huh? No, you fail to reject null hypothesis, okay. Now, you always have to say that you fail to reject null hypothesis. Then you can say that you accept null hypothesis. Fail to accept means you accept. Okay. You cannot use the term as you fail to reject alternate hypothesis, and because of that, you accept your null hypothesis. This is wrong. Okay, it's not the other way wrong. Cannot.
So you must say fail to reject.
Yes, correct. Okay. Although as you go further studies and so on, a lot of people don't even use the term fail to reject null hypothesis. You just accept null hypothesis. It's like taken to be the same case. Okay. So it is the point whereby there is insufficient evidence to, okay, there is not enough evidence to find a person guilty, therefore the person is innocent. It doesn't mean that person has to be innocent. That's what it means. Okay. All right. Okay, just follow this concept first. It's much easier for you. Huh? Just follow it. At least it will be easy for you as well. No, if you reject null hypothesis, you automatically accept alternate hypothesis. Yeah. Okay. So the easy way is to follow this style of writing. Okay. You can say that since your T, okay, it's actually one of these two styles. Let me just write down. Style number 1. Okay. Since, let's say it can be T or Z, it doesn't matter. That is more than your T critical. Okay. Or another style you can write is the p-value is less than the alpha. Okay. If it's more, then you reject null hypothesis. Reject null hypothesis. Hence, you accept the alternate hypothesis. Full stop. This is the decision. The interpretation is therefore, and this whole part, you explain what the alternate hypothesis means. Hypothesis means to the question. Huh? Which one? What are you talking about? Not bracket. This is what you put inside. So you write what the hypothesis actually means. Okay. So this is a template that you use for rejecting null hypothesis. Okay. The template used to accept null hypothesis is since, let's say the T is less than the T critical, or the p-value is more than the alpha. Okay. Then you say you fail to reject null hypothesis. Hence, you accept. Fail to reject what? You fail to reject means you have to accept. There's only two choices. Either you accept null hypothesis or you don't accept null hypothesis. Yeah. No, that's why you have to fail to reject, then put accept. It's because you fail to reject, that hence you accept. It's a sequential step. Fail, reject. Oh. Okay. You fail to reject null hypothesis, hence you accept null hypothesis. Therefore, then here you write what the null hypothesis means. Okay. So just follow this template. These are the words that you change. Either one. You pick either one. Huh? H. Yeah, accept H1. The bottom one is accept H0. Yeah. Yes. If the null accept, don't care about alternate. The moment you say, if you accept null hypothesis, right? That means, let's say 2, and then you continue saying now alternate hypothesis, you're going to get it wrong. Don't. Yes. Once you fail to reject null hypothesis, accept null hypothesis, don't even talk about alternate hypothesis. You are going to get it wrong. Okay? You can think about it in a different way. It is this. The way you can consider is that null hypothesis is the default condition. When the default condition happens, don't talk about alternate condition. When the default condition happens, don't talk about alternate condition. Situation. So then let me ask you a very simple question. When you do your test or exam, what is the null hypothesis? No. When you do your exam, what is the null hypothesis here? Null hypothesis is you fail. Yes. Null hypothesis you fail. Alternate because it's more than, then you cannot be deemed to fail, therefore you pass. If you exam the null hypothesis is you fail. Whether you come for test or you do badly or you don't turn up, you will still fail. That's the default condition. Only when you do better, therefore you are not considered to fail, therefore you pass. Cannot. No, it doesn't. Yes, correct. Okay. Okay. The reason is it has to do with how many data points you need to consider each one. No, even more than that. Yeah. Okay, let's say if you have I can't remember how to do this properly, but let me try. Because I haven't done this one. So you say that this statement. All swans are white. Okay. No, all swans are white. How do you prove that all swans are white? No, so correct. So the question is, how do you prove this statement? Versus how do you prove this statement correct? Versus how do you prove this statement wrong? Correct. So in order to prove this statement wrong, just find one swan that is not white. But to prove this statement correct, you have to look at all swans, dead or alive, and even yet to be born. Yes, correct. So how is that possible? Correct. So that is why we set null hypothesis to prove it wrong. We set null hypothesis to prove it wrong rather than set null hypothesis to prove it right. So this is the null hypothesis. It's easier to prove the null hypothesis wrong than to prove the null hypothesis right. Yes. It's our other if the null hypothesis is wrong. Yeah. Which one? Which one? How do I go back previous? I can do it. No, I can't do it. Previous slide. Kind of erased it already. Okay. Okay. So that is the basic concept, but we spent too much time on it already. So let's look at the tutorial question. No, the lab questions. Okay. But in lab questions, what happened for the first lab today is that Excel cannot do a one hypothesis testing for you. So how does Excel actually do one hypothesis testing? Or what does one hypothesis testing looks like? The type of research question will be things like you are whether the average weight of average weight of, let's say, a cup of others ice cream. Not really, I haven't eaten before. Is 60 grams. Okay. So whether it's the cup, let's say the others ice cream print there 60 grams per cup. Your hypothesis, you want to test whether is it 60 grams. So what you can do is your null hypothesis says that the average weight is equal to 60 grams. The alternate hypothesis, okay, it depends. It can be average weight can be less than 60 grams. Okay, this is one tail. It can also be the average weight is more than 60 grams. This is the opposite side, also one tail. The third one is the two tail. The average weight is not equal to 60 grams. That's the two tail. It depends on question. Correct. Must be larger. When it's smaller, must be smaller. So it depends on which context are you looking at. Okay. So for example, here, let's say others. Okay, let's say when you do your experiment, you collect 10 cups of others ice cream, and you find that the average weight is 65 grams. Will you be satisfied or will you be angry? You'll be satisfied, right? Yeah, good. You'll be satisfied, but the company will be angry. If it's less than 60 grams, technically, if 55 grams, the company is happy because it earns more, but you'll not be satisfied. Okay, so basically your one sample hypothesis testing is almost a quality control test. You do it for quality control. Correct. No, both can be quality control. So let's say, for example, you do this, you want to find null hypothesis less than 60, but the answer, the average weight they find is 70 grams. Do you reject null hypothesis? Yes. No, you still don't reject null hypothesis. No. Because why? Remember, at here, you look at your rejection criteria. So this is 60. Okay. But what happened is you want to be less than 60. So this is 0.05. So maybe your rejection criteria here is maybe 57. This is you. Anything more than that, you accept null hypothesis. Anything less than that, then you reject null hypothesis. It doesn't mean that even 1 cup is 200 grams, you still say that it is accepting null hypothesis. Okay. All right. So for two-tail test, it is the reverse. Let's say this is 60 grams, but maybe the two-tail, each one is 0.025. So here maybe 56 grams, here maybe 64 grams. Only when the average weight is between 64 to 56 to 64 grams, then you accept the null hypothesis. Otherwise, you reject null hypothesis. Okay, so that is a concept, essentially. All right, so let's go to your tutorial questions. Oh, not tutorial questions. Go to your lab questions. What? Go and watch the video later lah. Okay. So the problem is we cannot do one sample testing in Excel. We have to kind of trick Excel to do it. Okay. All right. So let's give a simple example first. Let's look at the others ice cream. Okay, so we have weight. And for example, you go and buy 10 cups and go and weigh them. Okay, so let's say you have 60. 61, 60.5. Then you have 1 cup that is 59, 59.5. You have 62, 61, 60, and 60.5. Okay, hold on, and maybe 61. Okay. All right. So once you do it here. Okay. So I'm just going to follow exactly what the lab notes give you, because I find that if I give you a different method, like what I did for last class, they're going to get more confused. So I'm going to make your life easier. Okay, so now what you need to do is you're testing it. So this is your hypothesis. Now hypothesis, the mean weight equals to 60 grams. Okay. And let's say we do a two-tail test. The alternate hypothesis is that the mean weight is not equals to 60 grams. Okay. But we need this thing called a dummy variable, because what happens is if you go to the data analysis tab, you go to t-test two sample assuming unequal variance, the last second one. Two sample assuming unequal variance. The last second one. Okay. You need to enter both ranges. You need to enter two sets of data for you to calculate. So in order to do that, you actually need what we call as a dummy variable. The dummy variable, you just put 0 for everything. Okay, just put 0 for everything. Make your life easier. Yeah. Yes. Okay, the dummy, you just put 0. Okay. So this is how you do it. Follow step by step. You go to the data analysis, look at two samples assuming unequal variance. All right. Variable range 1, you put your actual measurement, the weight. Variable 2 range, you put the dummy. Okay. The hypothesized mean difference, you put the weight that you are estimating. So it's 60 here. You type it in yourself. You can't click it. Okay. Data analysis, go to the last second one. It's in alphabetical order. Data analysis. We have been doing that for the last 3 weeks already. What? Later. Without dummy variable, it can't work. Then you go back to the first lab session, how you get the data analysis step again. Yours is not there, then you have to go to get it again. Later, not yet. Okay, anyway, after that, because we select the labels, so click on labels. Output range, you go to, let's say, another empty cell, then click OK. Okay, so you have to know how to get the data analysis step for yourself. We are not going to help you during test or exam or test. Why not? Okay. All right. Okay. So anyway, this is your T statistic. Okay, the T statistic is 1.64. The T critical value for two-tailed test is 2.26. Then, do you use equal variance or unequal variance? Which number is different then? Okay, you check which number is different. Oh my God. Okay. So based on this result, do you accept or reject null hypothesis? Look at the alternate hypothesis. Do you want, is it one tail test or two tail test? I already written there already.
It's one tail. Two tail, sorry.
Why?
Because it's not equal to 60. It can be less than 60 or more than 60.
That's I didn't know that.
You accept null hypothesis, correct? Because the t statistic is lower than critical value. The t statistic is lower than critical value, or the p-value, this is the p-value, is less than the alpha, which is 0.05. Alpha is what you decide. Okay. There's actually beta if you want to know. In fact, we'll talk about beta when we come to the two sample test, which is next week. The following week when you come back for your term break. After your next week, after next week is term break already, huh? Then after your term break, then we come to the next part lah. Okay. So essentially, so based on this itself, okay, you say that since the t statistic is less than the t critical, you fail to reject or null hypothesis, hence you accept the null hypothesis. Therefore, what is null hypothesis? Average weight is 60. Average weight per cup is 60 grams. If you use the p-value, then you write since the p-value is more than the alpha, which is 0.05. Similarly, you fail to reject the null hypothesis. Hence, you accept the null hypothesis. And please make sure you follow the same punctuation as well. When I use semicolon, when I use comma. Okay. The punctuation before the word hence has to be semicolon. Cannot be comma. Why? Okay, if you put this, you take this part, from hence onwards is a complete sentence. Before that is also a complete sentence. You cannot join two complete sentences with a comma. That's called a common slice error if your English teacher never teach you. Huh? You can put a full stop. Yeah, no problem. That will be correct.
What?
You can put a full stop here and hence is capital. In fact, hence, therefore, all this has to be the start of a sentence.
Why? How that is a full sentence? What makes you think that a full sentence? Maybe it's half a sentence?
You can go and ask the teacher and see what happens.
What makes me teacher? What makes? I know.
Okay, so anyway, so that is a final solution. Okay, but you have to know which one to read your one tail or two tail test. Yes. Don't bother about that slide. Yeah. Technically, failing to reject null hypothesis really doesn't mean that null hypothesis is correct. That's true. But you have no other option here. Then you go and find another option. It's a default. So it's always a crossroad. One side of the road is null hypothesis correct. One side of the road is alternate hypothesis. If you say that null hypothesis is there, go and find another test or go and find another alternate hypothesis that proves that the null hypothesis is wrong. Yeah. Okay.
But then in the sample answers also they include there is insufficient evidence or sufficient evidence.
Correct. If you want to write more, then you use the word sufficient evidence or insufficient evidence. This is where there is insufficient evidence to reject null hypothesis. It doesn't mean that null hypothesis must be correct. Okay. Yeah. Okay. So in other words, right, what does this p-value means? Remember, this p-value 13.4%, it simply means that based on these results, 13.4% of the time null hypothesis is correct. Yes, only for two-tail. So 13.4% of the chance null hypothesis is correct. You can only reject null hypothesis when null hypothesis is less than 5% chance of being correct. That's what the slide is trying to tell you. You can only reject null hypothesis provided null hypothesis is less than 5% chance of being correct. Or what is the alpha value here?
So higher significance
level, higher significance level is harder to reject null hypothesis. Yes, hardest because higher significance. Let's say you use 99% confidence. That means if the null hypothesis is less than 1% chance of being wrong, then you say the null hypothesis is wrong.
Less than 1%.
Then you say the null hypothesis is wrong. So isn't this? You can only think about this. You can only reject the null hypothesis if the null hypothesis has less than 5% chance of being wrong, of being correct.
Wait, wrong, correct?
You can only reject the null hypothesis here if the null hypothesis has less than 5% chance of being correct.
So in that instance, the hypothesis is correct.
Right. Yes.
So the 99% just now, you said the 99%.
Yes, you can actually increase it.
So that means only if it's 99% and above, then it's
99%.
So if let's say it's 1 tail, right, it will also pass, right?
If it's one tail, yes, because
Because
it's still 6.7% chance of null hypothesis is right.
Okay, so if I say 20%,
Yes. Okay, so then you bring out a question. Why do we use alpha equals to 0.05 or 5%?
because the confidence level is high.
Not really.
Yeah,
Yeah, so why do you choose 5% and not another percentage? That's what I'm trying to ask you.
And give the confidence percentage.
It's not easier to do. You realize, okay, so there are actually a few reasons. Number one is it depends what is the convention. General, the accepted convention is 5%. The critical is 5%. So think about it. When people need to print statistical table, they need a certain regular type of units to print. They cannot print 5%, 6%, 7%, and all this. Then the whole table will be a book by itself. Right? But 5% also depends on the area that you are using, the field of study that you're using. if you are doing other forms of medical science, you can use 10%.
So what requires something that's like, oh yeah, what? Oh yeah. So basically, if it's higher than these.
Okay. So the question now becomes who produced this 5%? Who came up with this 5%? No.
We're not looking at like how risky it is.
Yeah, it's actually looking at how risky it is. Okay. So now, who came out with this 5%? There's actually a few. Yeah, it's actually not important. That's true. So what happens if more than 5% or less than 5%? What happens?
Then you should have a higher chance of it being.
No alpha then higher chance of
All right. So let's go on to the next part. Okay. So let's look at the heart rate problem. You can do the heart rate problem yourself. Task number 2. So your heart rate, put it in yourself, 66, 77, 80, 80, 82, 66, or 70, 2, 4, 6, 8. Yeah. 69, 91, 87, 88, 54, 89, and 61. Okay. So what you want to test here is the null hypothesis that the average heart rate or the mean heart rate is 70 beats per minute. In this case, what is the alternate hypothesis? Is it more than, less than, or not equals to? What's the alternate hypothesis? Is it one-tail test or two-tail test? Read the question yourself. Task number 2.
It's like the lab menu. Yeah. Come back to you.
Two-tail test, correct. So the alternate hypothesis is the mean heart rate not equals to 70 beats per minute. Okay, so can you repeat exactly the same method as what we did for the ice cream problem?
So we just say the same equal variance.
Yes. Yep. So you have a dummy variable again. Because without dummy variable, it will not work. You need to have 2 different components here. So here, hypothesize mean difference, you put it at 70. Okay. And if you do it correctly, this is your results. Yes. Huh? Okay, if you want to change the different p-values, that means you want to estimate the different p-values, then you change it here, the alpha, the total alpha. Let's say you can go to 0.01, you can go to 0.1, depending on the question itself. 0.05. If it's not stated, it's always 0.05. Yes. Okay. Okay. So with this result, do you accept or reject null hypothesis? Correct. Okay. So you say that since the p-value is more than 0.05, you fail to reject the null hypothesis. Since you accept the null hypothesis, therefore, average heart rate equals to 670 beats per minute.
So then you use T to decrease. Since T is smaller than T3, so to reject null hypothesis.
T is more correct.
And accept null hypothesis.
Yeah.
So in the question, you either choose to use
Okay, if on Excel test you can choose either one, but on paper test you only have the T critical to use. Yeah.
In what situation are
In paper test.
you? There's no sigma in unknown. Then the sample size is more than
We're talking.
correct.
So wait. So if the T critical is higher than the T stat, then you accept.
You use the T stat, is it higher or lower than T critical, not the other way around.
Oh, so like if the T stat is lower than
Yes.
T critical.
Yeah.
So how come you cannot do that way around?
You can, but you just confuse yourself. If there are two ways of writing, you will definitely confuse yourself. Okay. So else you'll be writing this: since T is less than T critical. Yeah, correct. Then you do the same thing. You can also write it in the opposite way, that since T critical is less than or is more than T, and that will just mess your head up. Why would you want to do that? That is correct. But once you put the symbol wrongly, the whole question becomes wrong.
But what if you don't want to put the symbol, you just want to say lower than? I feel like the symbol is kind of.
Yeah, you can write it out as well. Okay. Now, how do we mark during tests or test papers and so on? It does depend on a few things. Number one is, if everything is correct, you get full marks. That one is easy. Yeah, everything is correct. From top to bottom, everything is correct, you get full marks. Okay. But on the stricter sense, if you get the conclusion wrong, everything can be wrong.
So you don't get method mark.
You don't get method marks. Depends on how strict you want to mark it.
So it's supposed to be
You either get full marks or you get.
Yes, but yeah, you can. That's the strictest way of marking. The marking. The most stringent one is if especially a conclusion you write it wrongly, everything can be wrong. You can don't read anything else. Yes, why not? It doesn't matter. Conclusion is wrong means wrong. You cannot do your pH. You cannot go and take your solution, measure pH, and pH is 8, and then you go and write the salt concentration is 8 milligrams. Conclusion is wrong, everything else wrong. I don't care what you do.
Everyone that can mark the thing will see that you wrote an error, so the one is that one.
Not really. People will look at the last result. It's just like newspaper, you only read the headlines.
Oh, but you read the headline and then you read the thing.
Yeah, half of the time is you don't even read that. You don't even read anything.
So technically the mark that is indicator is just based on that sentence.
Correct.
And then you will just go back to see whether
Yeah.
he hit the
Yeah. Okay. All right. So now we go to your diabetes again. And we want to test. Let's look at task number 4. Waistline is below 40 inches. Okay, take your entire waistline. Copy out lah. Okay, so your null hypothesis here is that the mean waistline is equals to 40 inches. The alternate hypothesis is what? Read the question.
It's below, so it's below.
Yep. So mean waistline. So it's actually a one-tail test. So similarly, you can do the rest part. You can have a dummy variable 0, 0. Okay. Then you do. Yes, that's 4. Okay. So you change to 40. And this is your result. So in this case, do you accept or reject null hypothesis? So you have to learn how to do it fast enough that in half an hour, you can do about 5 to 6 questions, including writing things out, typing the data in. Why do you accept? What is 0.05? Yeah, 2.1. What does E minus 12 means?
Very low.
I already mentioned to you last week. Yeah. Correct. So the p-value for one-tail test is 1.1 times 10 to the power of minus 12. Is that more than or less than 0.05? That's all. Right. Yeah. Doesn't matter. Huh? Yes. Makes your life easier as well. Yeah. No. In this case, you always modulus your t. Yeah. What?
Oh, so the question is asking 1 to 1, then you look at the data of 1 to 1.
Correct.
So you looking for 2 0, then you look at.
Yeah. So here you say that since the t is actually larger than the t critical, so you can put the modulus. Put the modulus yourself. Put modulus is easier. Otherwise, you have to put the reverse. In fact, the t is lesser than the t critical. Lesser than the minus t critical to be exact.
Why don't you say that the T is lower than?
is lower than the minus t critical. Because it's not just lower. This is why if you put the use the reverse, right? Use the negative part of the equation of the graph, then everything flips. So why do you want to do that? So that's why you do an absolute t value. Makes your life easier. No, just write it in yourself. You don't need to type. So it is no, it is above this shift this thing. I don't know. You have to know your keyboard. Yeah, check. Hypothesis. Correct.
Then reject null hypothesis.
Yeah, correct. Okay. So this, whether you accept or reject null hypothesis using the p-value or t-value is extremely critical. Don't make this mistake. Whether you accept or reject null hypothesis using either the p-value or the critical value, make sure you don't make a mistake here. Okay. Not just for your diploma, but if you want to go uni, it's the same thing. Okay, I know of somebody who failed his entire master's degree because he wrote this thing wrongly. And the examiner's report says that this person doesn't even know basic statistics, hence he shall not pass. Yeah. And the best part is he cannot resubmit again. He basically wasted his 2 whole years. Fundamental errors. If you make this mistake, it's as good as saying that pH less than 7 means that it's alkaline. It is the same mistake that you have here. Yeah. Okay, but don't be surprised. I also know of students who say that -1 is less than -10. Good. Okay. Okay, so now we're doing the Z test. Correct. Okay, so what happened is, let's say if you want to do the Z test for this waste. Okay. So we copy the waste and the dummy. Waste and dummy to the next sheet. But okay, Z test is a problem in a way. We never actually do Z test in real life at all. Why? Okay, because number one, we almost never know population variance. Okay. Sample size can be more than 30, that's fine, but we almost never know population variance. Because if you know population variance, you study population. Correct? That's too expensive. You can't do that. That's one thing. If you use sample variance to estimate population variance, you technically get it wrong. It's only an estimation. It may not be correct. Okay, of all the biases and so on. Okay. So we never use, in real life, we never use that test.
So it's a theory.
It's theoretical. But we need Z test because T test is built on top of Z test. Okay, that's why you need the basics of Z test first. And because of that, Excel, you can still do Z test. It is more tedious. A lot of things is not calculated for you. Okay. So if you look at Z test, which is you go to the data analysis tab, you go to the last one, which is Z test to sample for means. You realize that there's one more component that I put in called the variance. It doesn't calculate the variance for you. You put in the variance yourself. So you calculate the variance of waste, variance of dummy, put it in yourself.
You need to ST them.
Yeah.
Oh my god, bro.
Okay. So this is why it doesn't calculate for you first. So what we need at the moment is that you need to calculate the variance, not standard deviation. Variance for waste. Yeah, or you can use the variance. So we are using it to estimate. Again, this is not going to be correct. Yes. Yeah, you can. You provide that as well. Okay. So what you do is you go to data analysis tab, sample one, variable one range, variable two range, you put it in. The hypothesized mean difference is the same, so 40 inches. Variance one, you cannot even click, you have to type it in yourself. So you put in 32.98. Variance 2, what is the variance for all the zeros?
Zero.
You put in 0, it's not going to calculate as well. Okay, you can try to put in 0. Can put in 0, right? Then the labels, you have the labels, the output range, put, let's say, column F1. Okay. See? Variance 2 must be a number larger than 0. So basically, you have to put in a very small number. 0.0001 or something like that. That is you want to estimate waste, is waste equals to 40 or not? Okay, then you can calculate. Okay, so you end up with this. You see that the Z statistic, variance 2, yeah. Okay. So you realize that the Z value is very similar to the T value. Now let's put something very low. In fact, it just has to be much lower than variance 1, that's all. Even you put 0.1, it's still okay. Just that the Z statistic come out with a slightly different number. Okay. So you realize that the values for T and Z statistic, the values are almost the same. Okay, up to the third decimal place. But the the P value is very different. One is 2 times 10 to the power minus 13. The other one is 1 times 10 to the power of minus 12. So it's tenfold difference. But nevertheless, it's still below 0.05. Now, during your test, we are a bit kinder. We do not give you a calculation that the p-value or the statistic is very close to critical value as well. What I'm trying to say? T-test, Z-test, or anything. When you come to ANOVA, it's a totally different story as well. Okay. So what happened is you just at this moment you are touching the first type of test. Okay. Only one. Really only one. After that, yes. Yeah, right. You're absolute. Okay. So let's see what test do you have now? You have your one sample. Let's say in your syllabus, one sample T test, one sample Z test. Okay, then you have two samples T test or Z test. Okay, then you have this thing called paired T test. The next thing that you're going to do is not a test, but let's say prefer. That is your regression. 5, you do your one-way ANOVA. 6, you do your Mann-Whitney U test. Yeah, this is a name of the person. Because this is not exactly a test. It's a method. These are your least square line. Yeah. Mann-Whitney U test. Then your Kruskal-Wallis test. Which one? Kruskal. Then your chi-square test. Huh? There's no, every test is used differently. So these are all the 8 different topics that you are covering from now on. Yes. Because it's the basis of science. Science is always you try to reject a null hypothesis to get an alternate hypothesis. You move down that road, then you hit another hypothesis. You either accept or reject, move another road. It's checkpoints after checkpoints. Yeah. Okay. So for your whole BDA, this is all the tests that you're doing. And you have actually other things, like for example, there are, let's say one of the topic will be confidence interval. There's a little bit confidence. Huh? What? Log and ln. Log and ln is not within here, but you're expected to know already. Yeah, it's supposed to be taught in your secondary school. Too bad, lor. Suck your thumb. Okay. So basically, these are the 9 topics for the next until August. Term test 2 is mostly everything, yes. Okay. So term test 2, what we are giving you is the data, and then we actually, our best question is perform an appropriate test. Then you're going to pick up which test you want. Okay. So yes, in fact, after the first year that we run this course, this BDA, we trimmed down a lot of the syllabus already. Yes, we trimmed down. We trimmed down especially on these two. Man-Whitney U test and Kruskal-Wallis test. No, the Man-Whitney U test, Kruskal-Wallis test, actually there's another, there may be one more, but these three we trim down so that you do not have to memorize the steps anymore. The formula sheet doesn't help you in these three tests. The formula sheet doesn't help you because the rest of the test you are using average, mean. Mean, you can put all the numbers into a calculator and it will give you a formula for mean. But these three tests you are using median. So you have to take the data, sort the data yourself, combine, resort, pull it out, and then resort again. All these three tests is done differently. So the batch that just graduated 2 weeks ago, yeah, they're the one that really at term test 2, all their face is like ghastly. Yes, they have. So we give them data. They really just write down how to sort, how to do every single steps. There's only one question, correct? Okay. You can go and look at my video. That is the non-parametric part. Okay. So anyway, these are all the tests that you have to do. Then see you next year, lor. Yeah.
So
Next semester? No. This semester I only teach BDA, yeah, because I got 2 classes already, ma. So I already covered 8 hours plus my leave is one enough. For what? Teach what? Yeah, I do teach bio. Okay, so anyway, for the next 15 minutes, you can use it and check, use this t-test, z-test, check your tutorial questions. Those that have the numbers, then you put in. Okay, so any problem? Okay, so that's all. So I'm stopped recording for this.